Welcome, everyone. Thanks for joining us on our webinar today, which is part 4 of a 4-part series on robotics. And today's topic is on the robotic applications. I'm Rose Kapsha from Tooling U-SME and your moderator for today's session. Many of you know for over 90 years, Tooling U-SME has promoted the advancement of manufacturing by supporting new technology in industry and the development of its workforce. One quick tip on your screen today, you have a Q&A box where you can enter any questions you have for our speaker today. We should have time at the end to answer some questions that you might have. We will have a recording of today's session will be made available on our website as well. At this time, I'd like to introduce our instructor, Mr. Herb Pierce.
Thanks, Rose. Hello, everyone. Glad to see you guys on today. So yes, today we're going to be finalizing the 4-part series and talking about robotic applications. So in previous postings, we've done intro to industrial robotics, robot safety, maintenance and troubleshooting, and then finally today with applications. So mainly there are a few different types of robots out there. We're specifically going to talk about these 4, which are the articulated robot arms, the Delta robots, the scare robots, and the collaborative robots. So in each one of these applications, whether you talk about the big players from KUKA to ABB to FANUC to Universal Robotics, with the exception of UR on the traditional robot types, KUKA makes both the robotic arms that you see here. They make a Delta robot. They also make a collaborative robot, whereas ABB is the same way. They also, right here's pictured a Delta robot, and a lot of this we went in the intro, but I'm kind of touching lightly on it today. The Delta robot that ABB makes, they also make a robot arm. They make a very unique collaborative robot that actually has 2 arms on it. And then they also do, of course, the robot arm. Also, when it comes to, and they also do scares. So both, I don't know if, actually, correction, I don't know if KUKA does any scares, but I do know ABB does. When it comes to FANUC, so FANUC does all the above. They also have robotic arms. They have the Delta robot. They have the SCARA, which is pictured here. And they also have a collaborative robot. Now, however, when you come to Universal Robotics, and the collaborative series, Universal only at this point in time makes collaborative robots. That's just a quick overview. When it comes to applications, you want to take a look into what we talked about in the first slide. When it comes to industrial robotics, the intro, refer back to that video talking about how you want to set up the cell and how you want to go about safety with part 2. Kind of leads into these next steps of understanding how these robot applications take place. So with our first application, we're going to talk about is palletizing and depalletizing. So whether you're doing bottles or cans, a lot of times when you see depalletizing, typically that's in the bottling industry when they're going to take an empty bottle, or even in the oil industry, the petrol industry, I've seen where they take empty bottles, they'll move those bottles onto a line, or maybe it's some sort of empty box. Something that's typically empty is going to be depalletized from a system and then put that onto a conveyor belt of different types. Could be a conveyor, could be an airway, could be whatever. It's connected to a series of things where they take it from a bulk system, place it on some sort of conveyance, and then they take it to the accessory equipment. That's on the depalletizing side. So on the palletizing side, it's the reverse, where the finished good is made. It goes down the conveyor system. It'll get fed in through some sort of metering conveyor, and then the robot will then go down with its specialized tooling that's designed for the EOTs. It will then pick up the object. A lot of times I've seen boxes. There's times I've seen bottles where it actually, the company made bottles. They had some blow mold technology. The bottles are made and they palletize the bottles up to a stack. They put some sort of strapping system to it and a top sheet layer on there. And then that all went through the systems. So there's many different things that can happen with the palletizing side. Typically, you'll see different conveyors and sorters where they'll do different pack patterns. I've seen a lot of times that when you're palletizing boxes, that they'll have even a Scara robot orient the boxes to a different position as they're coming down the line to make a specific pattern. There's times they also use pneumatic valves. So you can get very, very creative when it comes to the point of palletizing. Some of them are what they would call high level. So the robot might be mounted up in the air on top of a system, on top of a machine. They also have low level palletizing where the robot is literally at the ground level, and all the equipment or all the boxes will then come in, get sorted out on the sort conveyor, and then get brought in. Some of them are staged. There's different examples. I don't have them pictured here, but they may use 3 to 4 different robots. They may have 2 robots doing the sorting. There'll be a robot that will actually do the layer placing. And then if there's tier sheets involved, or there's thin pieces of cardboard or paper that are put in between the layers of a pallet, that is also done as well. When it comes to the palletizing situation, again, you can get very, very creative. In this picture that we have here, they're taking some sort of bags or objects that are in a bag. It has a fork style eyote that then goes down and scoops up the object, and then of course palletizes it onto a pallet. So as creative as you want to get is as creative as that you can go. Basically, these are automated systems that you'd find sometimes deep in the warehouse, bolted to the backside of a conveyor system that's from the production line. I've seen also scenarios where they've put palletizers together, and it was one palletizer that was responsible for 4 or 5 different lines, and they pre-staged up all the conveyor systems to then go to that one robot. It really depends on what scenario you want to do, what kind of system you want in place. I've also seen where they've had 5 production lines and 5 palletizers. And then, of course, that'll get connected to a stretch wrapper. So there's many, many different uses that you can have with a palletizing robot. And again, it could be complemented with other robots for either case orientation or case prep or object prep, many different scenarios. All right, for our next one, we have a material handling. So in this picture here, that's complements Fanuc America. They have a 3D scanner. So you see that light array that comes down from the top. It will then identify where the part is. The Delta robot will then take its XY coordinate and identify across the Cartesian coordinate where is that object placed, and then sorts it to where it needs to be brought all those parts together. And then you can see that the robot arm will then gather, that's the second robot downstream, will then gather what the product is and then place it on the conveyor to be then brought down into the system. So there's many different ways that you can also do some material handling. I've also seen where you can use, back in the first photo, which is this is actually a Fanuc M410, you could also utilize this for material handling. So material handling is a broad term. It's basically handling material. I'm going to take it from one point to another. Things I don't have listed here could be a AGV, which stands for autonomously guided vehicle. That is also a type of robot that I didn't cover in this webinar, but that could also be utilized for material handling, where you could have a robot arm pick that product off the conveyor belt or off the staging area, drop that into the AGV or onto the AGV, whatever tooling is sitting on top of that. It then transports it to the other location, maybe another robot arm or some sort of delivery system that it will grab and then bring that on there. So a lot of times you'll see material handling plays a crucial role in streamlining logistics, optimizing workflow. There's many different aspects and avenues that you'll see material handling. Again, as creative as you want to get, as creative as that you can make these robots do whatever you need to do to achieve higher productivity and to also work with material handling. I've even seen scenarios where large coils of steel that needed to be rotated for a specific task that may needed to be done in the factory. Again, that's material handling. So this is just a basic observation here. It looks like on this conveyor, they actually are using batteries to orient, to put them into a specific package to then be sorted off to some sort of drop packer or packaging system. However, I don't know however this photo works downstream, but that's the aspect they utilize it with. The next application, which is extremely popular in many different industries, is the pick and place application. So this one here complements of ABB. There's actually within this machine, You can see in the background, there's a cell there and a various types of conveyor. So this is bringing product down. I'm not really sure what the product of bags of juice. So those bags of juice are coming down the conveyor belt. There's also, I can guarantee you by the way that conveyor belt is lit up, there is a camera that's identifying where this product is. Once that camera identifies the orientation of where that bag is and the position, and it utilizes an encoder. I don't know if I think we did talk about that in one of the earlier webinars, knows how to track that product as it goes down the conveyor belt. The robot will then come and take its pick location. After it has it picked up, it will then drop it into the box. Most likely with this system, I'm going to assume there's probably also a box maker or box erector robot that created these boxes to then bring them into the system. The robot would also know through the logic to understand where the box is placed, again, using another encoder on that conveyor at the bottom part of that photo to then track that case, to then have that robot place that in there. Typically, what you would see in this style with these robots, there's quite a few of them in this system, they would probably do like a lead lag system in the recipe. So it would identify, okay, the first 1 or 2 bags would then get picked by the first robot. The next bags of 3 and 4 would then get picked by the second robot. And then they would cycle back and forth. And that's how they can achieve higher speeds and higher rates. Of course, I don't know. We could really never know by looking at this picture how fast are they running. But I mean, I can imagine they could probably pick close to 100 bags a minute with that style setup. And of course, if the customer requires that the system need to run faster, well, you could easily just put more robots in there and do a lead lag system on those recipes when it comes to calling the bots of which one needs to pick the product. Typically, I'm sure at the bottom end of that conveyor system, there's probably a catch to where if the robot did miss it, it could recycle it to bring the package back around. Those are some things that you might want to take in mind, when designing a system like that. So again, commonly pick and place. I've seen it in a variety of applications where if it's in a factory and they need to box packages coming down the line, I've seen pick and place where they've made like noodles and in packages. Again, 3D scanner would pick it up. It would pick up the box and place it into its orientation and the box that's coming by, just like you see in this photo. I've also seen in logistics operations where there's pick and place for which conveyor belt it may need to be sorted to, or maybe even it's a tote that's brought in of just scattered materials sitting within a box. We'll use like some toys, for instance, some small gadgets or toys, and they're brought in this box. The robot would then do a 3D scan of that box. It will grab the object, place it onto a conveyor, or it'll grab the object and then place it onto another box for sorting. So again, pick and place could also be utilized in just sorting things in a mass container. So there's, again, as far as you can imagine these applications to be done, these are the ideal places you can use for pick and place for cost-effective solutions. The next one that you'll see, which is very common, is welding. Usually within welding, where you want to utilize robotics is areas in the shops to where you're doing a lot of fixture placement, or you're doing a lot of welding, or there's a lot of the same thing going on, car manufacturing, specific molds or things like that need the specific weld. That's when you want to utilize the welding robots. So again, welding robots are fitted with welding equipment. They could use torches. They have feeders, shielded gas systems that are capable of performing different types of welding. One of the greatest things about the welding is you're getting consistency every single time. So again, if you have many different fixtures that have to be welded that are the same exact thing over and over again, a welding robot is the best place to go because of your accuracy, the consistency, the high level of that with that quality weld to the joint. Some of these robots, depending on the brand, have sensors that are integrated into there that are equipped to know force and torque. They can also know where the seam is. So going down the seam, they can be programmed to sense that. There's many, many different things to achieve that optimal results when it comes to welding. We could probably even do a whole separate webinar if the request is there to even look at just specifically in welding. But if you're a manufacturing tool or machine shop, welding is a really good place for you to get to as far as keeping the capabilities extremely focused and have consistency in your welds. It'd be a really good place. Then you could utilize the welder that might have been doing that job to be able to use him elsewhere within the shop. So welding is a very, very good application to use for that. Actually, here I misspelled that one on there. I apologize for that. But this one's machine tending. It should have been not welding. Made a mistake on my slides there. So machine tending also a lot of times in machine shops. They have a batch system where they're making many of the same products over and over and over again. You don't have to have somebody standing there at the CNC machine waiting for the parts to get done, load the parts up, remove it from the chuck, put it on the little object that it may be palletizing to, or this little jig that it's going to. I've been in a machine shop where they were putting some sort of Loctite style material on screws, and the gentleman that was doing the job was just completely bored out of his mind. Literally, all he would do is take the screw and put it in this some sort of jig or fixture, and then hit the go button. Well, that could easily be replaced by a machine tending robot that could have, say, 3D vision scanning on it, could then look at the tote that it may pick from, its assorted bin, pick the object up, place it within the chuck of the CNC machine, let the CNC machine do its job. The robot could then pull it out of the chuck, put it to the applicator. You could even have it do a quality inspection with another camera and then put it in the bin. And that person can be used elsewhere, either to monitor every now and then or to go do another job that may be more important in the factory. So when it comes to machine shops, it comes to automation, machine tending is a really, really good place to go where it's just repetitive work over and over and over again. Because a lot of times I'm seeing that in repetitive work, we're human. Our bodies get bored. We're like, oh, we're just putting this in here in and out all day long. You're going to make mistakes. So if you're looking from a very good quality perspective, going to the machine tending angle is extremely, extremely important. It also keeps up with efficiency and throughput. And there's many different ways. I've even seen some pharmaceutical places to where they're making different parts and they utilize the machine tending robot to be able to put everything in the fixture, put it in the system. The system's done it. The robot pulls it out, then takes the object, places it in some sort of tray. And that tray can then get conveyed on to whatever other process that they have. So these are things to be aware of. Again, you can get very, very creative. The main thing when it comes to robots is trying to look at safety. So if there's a hazardous thing that you're doing in your process, you might want to identify a robot to use it. If it's something that's repetitive, that's over and over and over again, a great place to use a robot. If it's a situation where it's strenuous on the human body by picking up heavy objects, again, that's a place where a robot can be utilized. So these, again, you can be very creative with it. The next one, which is extremely popular, is packaging. So this robot here is actually looking at a drop packer. What's really cool about this is they have a box erector. So the robot to the right will grab the boxes, make the box, then put it through a tape machine, and then put it right onto its conveyor. The robot then will grab the product and then drop it right into the package and then send that on through a tape machine. There's kind of a pick and place thing that you may see going on in here. That is very true. When you call into packaging, it could be a pick and place. Again, it's creative on how you utilize the system. But I enjoy seeing robots, especially when the OEMs get very creative on how putting these together. A lot of times you're going to see these are just custom things that need to be done that you just can't use a generic cookie cutter machine for. But again, you can see here that these robots are specialized to do the pick and place, and the tools and the EOTs and the pneumatic systems are just as important as the robot is. So these are great places to keep up with speed and efficiency. The next one we'll go to is pretty popular, especially in the Cobot series, when it comes to painting and sanding and coating. So I know specifically for FANUC. FANUC, actually, what I do not have pictured here, makes a specific paint robot that could go in a paint booth to paint cars, for instance. When it comes onto the cobot side, and that's what I have pictured here, this robot is utilized courtesy of Robotique. They have a specific sanding tool that can be utilized to sand the whatever you need, whether if it's metal parts or whether you need to sand or buff out metal parts or even sand wood, whatever you can think of, it's sanding and buffing. They also have applications to where if you need to coat things, those are things that you could utilize this robot for. What's really, really unique about the Universal Robotics, they actually have a force torque sensor. And they have specific instructions that you can set up in there to where you can have the robot go down and it senses the part and then it puts a little bit of pressure on it and then does its push for sanding. So you have all these really, really cool and unique options that are built right into the cobot that you could program to have it do applications such as sanding, and whatever else the mind can think of. But these are some different applications that you can utilize. So pretty much pick and place with the capabilities, but also with sanding and different things of that aspect. The next one we're going to look at is manufacturing assembly. So you could utilize this when it comes to even cobots, typical industrial robots. You have the capabilities of doing manufacturing assembly. Again, this is another photo complements of Robotique where they have screws that are fed into the feeder. Then the screws can go down and then, of course, insert the part. And you might have some other support robots put the fixtures together and place all these different parts together. So there's many, many different resources out there going to some of these commercialized facilities of looking at, okay, what does Robotique's tools have? You may have a specific OEM that you might work with. You can ask them questions about, like, what do they do? We can go further into what these tools can do, but if you have your mindset focused on putting together manufacturing assembly, again, these tools are really good. So this specific picture here, this robot, of course, the UR robot, goes down to that Robotique screw sorter. That actually goes down, and you put the metal plate or whatever it might be that you're there. That robot can then put a screw in. So go in and pick the screw and then put it right into its spot. Of course, you'd have to have it pre-drilled. Of course, Robotiques makes some other tools that it could do that for pre-drilling. There's many different applications. Again, this is really good for repetitive tasks, things that it might need to be done with efficiency and then throughput. Of course, now I have it open for questions, and I see I have one. Let's see here. So what's the quantity of break-even point that is common for justification that robot vision systems putting Loctite screws when the volume is 1,000 a month, 10,000 a month? Could you speak in that general? There is a number of general industries where we need to start having a conversation regarding bringing in a robot. All right, so that's a pretty specific question. So, I mean, when it comes to justifying that really comes to your business practice. I would speak to, if you talk with an OEM, say this is what you want to do, and then that OEM would come back, all right, here's your break-even point, or here's where it becomes profitable. This is how much the robot system costs. Then you got to look at how many products need to be made in order to make that cost-effective and justified for you to bring into your system. Again, as I spoke of before, that when it comes to purchasing a robot, putting a robot system in, a lot of it is, are you looking for throughput? Are you looking for quality? And of course, the effectiveness of what that application brings. That break-even point and justification is going to be basically called out between you and, if you're the company owner, the board of directors of your company. That all has to be made justified upon who, what, and where of what you guys do. But the main thing is to ask the OEM. They're going to put together cost analysis of what the cost would be. Then you have to put together your own cost analysis to find out how much is the payback period. I would even ask the OEM, okay, what do you believe the payback period is? These are parameters that we're looking for. of, here's our labor, this is how much it's costing us in labor, raw materials. Those are all things you need to put together as a plan in the forefront to understand what is the break-even point. Hopefully that answers your question. Anyone else? We got 5 more minutes for questions. All right, sounds like I answered Leon's question. And then while we're waiting for some more questions to come in, again, Tooling U, we can also do more webinars. Rose, who introduced me, if you contact Tooling U and ask for Rose, she can put you in the right direction to, we'll want some more webinars done. If you would like me to come into your facility, you can contact Rose. If you're looking for even for training, Tooling U's got many, many different avenues, such as online learning. Again, we can even come in and do training to your specific needs in your facility. They've got many, many different avenues that you can go with. Any more questions?
Doesn't look like there's any coming in, but appreciate you doing this webinar for us today, Herb. And if there's any additional questions, feel free to reach out to us and we will get those answered for you. And like Herb said, if you're interested in doing any training for your facility, just let us know and we will get that arranged.
All right, thanks everyone.
Thank you. Thanks, Herb.
Yep.